Today we're going to start our last unit in calculus, and we're going to look at derivatives of other functions. And today specifically we're going to look at derivative of trig functions. Now I am just going to tell you the derivative of these functions, and normally in class I would have done a little bit of an exercise with you. So you're welcome to read through section 4.1 and 4.2 of your textbook, and that will give you a little bit of an outline as to why the derivative of sine x with respect to x is cos x, and the derivative of cos x with respect to x is negative sine x. Okay, and so now, like I've done before, I am going to generalize these. So in general then, if y was to equal sine of something, of some other function of a triangle, then the derivative is cos of the triangle, and hopefully you guessed the next part, times the derivative of the triangle. Obviously then I can in fact write that as triangle prime cos triangle. Okay, let's see if you can guess the other one. So in general, if the function is cos of something, then the derivative is going to be negative sine of that triangle times triangle prime. Of course, can be written and simplified right from the beginning as that. So let's go ahead and try some. So for our first example, we're going to look at the function tan x, and of course we all remember that that can be written as sine x over cos x. So we'll go ahead and we'll take this derivative using the quotient rule, and hopefully you guess that on your own. Okay, on the bottom we end up with cos x squared. On the top, first we're going to take the derivative of sine x, which is cos x. Okay, then times the bottom. Then we're going to subtract the derivative of the bottom, which is negative sine x, times the top, which is sine x. Okay, and let's go ahead and simplify that a little bit. On the bottom note, I'm going to write this as cos squared x. Hopefully you remember that this is the same as this. You are going to need to use that idea. And then we end up with a cos squared x, and it becomes a plus sine squared x. And I hope bells are sort of going off in your head, and maybe you remember that as your Pythagorean identity. So that equals 1 over cos squared x, which could also be written, don't forget, as secant squared x. Okay, so in summary then, the derivative of tan x is actually secant squared x. So we could actually use this idea of rewriting all the reciprocal functions in terms of sine and cos to find out their derivatives. So I don't ever memorize any of the reciprocal function derivatives because you can always use sine and cosine to do them all. So our main focus will be on sine and cosine derivatives. Let's try some more. Okay, fairly straightforward, sum and difference here. First, we'll take the derivative of negative 2 cos x, so constant multiple, we leave our negative 2. Derivative of cos x is negative sine x. Okay, another one here. Here, though, we do have a little bit more complicated with the triangle plus a constant multiple, so leave the 4 there. We have the derivative of sine triangle, which is cos triangle, and then we have to multiply by the derivative of the triangle. And important that this is one piece, this cos 2x together. The 2 does not get multiplied into the angle, right? Definitely not. We don't want to do that. Let's erase that. Okay, and last term we can combine with polynomial functions of any type. As you see throughout this whole unit, we're going to start to combine all of our derivatives together, so that derivative is 6x. So with trig functions, we mostly do just some cleaning up of the derivatives, so we make them look a little bit nice. This 2 is going to get multiplied by the 4 to become 8 cos 2x, and then plus 6x. There's nothing else you need to do to that. We're just focusing on cleaning it up. Okay, let's try another one. This one we talked about before already, but I do want to just remind you that this is cos x squared. So we're doing a chain rule here. Hopefully you can see it. It's like a triangle squared. Okay, so we're going to do 2 times the function It's really to the 1 if you like. Obviously, you don't need that part, but just so you understand it. And then we're going to go in and do the derivative of the triangle, which is negative sine x. And again, we're just going to put that all together. We have a negative 2 sine x cos x. Doesn't matter which order you write those in. And you might just remember that this is actually sine 2x. Not mandatory to do this step at all. I'm just reminding you, if you ever were setting these equal to 0 and solving for them, that would be a useful tool that you would want, okay? So let's try another one. A couple simple ones that we have here. So in this one, I just want you to be able to see in this next one here that the x to the 5 is the triangle. So I want you to see the difference between question C and question D. Okay, so we're going to take the derivative of cos triangle. Derivative of cos triangle is negative sine of the triangle. You can have brackets or no brackets. It doesn't really matter. And then we're going to have to multiply by the derivative of the triangle. Okay, and we just clean that up. So that's what our answer would look like there. Again, brackets around the x to the 5 or not, doesn't really matter. Okay, we're going to get a little more complicated on this page. Let's start with, what does this one really mean? It means cos of 3t minus 3. And all of that squared. And I do want to make sure that you can see this is the triangle right there. So we have negative 2 cos of a triangle squared. Okay, so we got to start with our chain rule. So we're going to have negative 4. We'll leave it all alone. 3t minus 3, all to the 1. Again, we don't need the brackets to the 1. I just want you to see it. Times, now I'm going to go inside. Derivative of cos triangle is negative sine of the triangle. And then we still need to multiply by the derivative of the triangle, which is 3. Okay, and again, just cleaning that up, bringing coefficients to the front, right? I have a negative, and a 4, and a 3, so ultimately that's going to become positive 12, and then I have a cos of 3t minus 3, and a sine of 3t minus 3. Order you write those in doesn't matter, and nothing I want you to do with those, you just leave those alone. Okay, try one more. Let's see now if you can put it all together. First things first, when you look at question F, I hope you can see that it's a product rule. There are 2 separate pieces right there. Okay, so, and then let's see if you can apply all these rules and do the product rule yourself. Try it. Okay, so we have derivative of the first, sine triangle, cos triangle times triangle prime, times freeze the second, plus derivative of the second. Remember that this is a cos x to the 2. This is a chain rule. Bring down the 2, cos x to the 1, times derivative of the inside, which is negative sine x, times sine 4x. Freeze the first one there. Okay? Again, just some cleaning up to do here. We don't have to do too much, but we'll bring the 4 to the front. We can't multiply those cos x's together. They have different angles. Okay, and here we end up with a minus 2. We have a cos x, we have a sine x, and we have a sine 4x. I guess the only thing you could do to simplify a little bit further is you could factor out 1 cos x from both of them and a 2 or a negative 2 if you want. But again, that doesn't really serve much purpose because we're not setting it equal to 0, so you're welcome to leave it there like that or go ahead and factor out a cos x if you want. Either or doesn't really matter. Now, important to note, we can take all of our other type of application problems too, and we can apply trig derivatives to those application problems as well. Okay, so here's a simple one to start us off. We're going to determine the equation of the tangent line to the graph of this, and you are given an x value. Obviously here, if we're going to determine an equation, we will need the y value as well at that x value. So we'll go ahead and we'll get that right off the bat. So that means we need to find out f at pi over 2. Okay, so if I plug it in, I get pi over 2. I get cos of 2 times pi over 2. So we have pi over 2 times cos of pi. And hopefully you remember from advanced functions this lovely picture of the axis arms. Here's our pi. And this coordinate is negative 1 and 0 on the unit circle. Cos is x, sine is y. So that means that the cos of pi is negative 1. So the y value is negative pi over 2. So we will need that. We know that from creating equations. Let's go ahead and let's find the derivative. And again, hopefully you can see that this is a product rule. There's two pieces right there. So let's go ahead and apply our product rule. Derivative of the first is a 1 times the second, plus derivative of the second, cos triangle, so it's negative sine triangle times triangle prime, and times the second function. Okay, so again, just like I said on the previous page, we're just going to clean this up, bring monomials to the front. We end up with a minus 2x sine 2x. And we want our slope, which we remember from other units, is our derivative at pi over 2. So that would be cos of pi, it ends up being, minus 2 times pi over 2 times the sine of pi. Okay, so using again this picture right over here of the axis arms, we know this is negative 1. This, the 2's cancel out, so we end up minus pi. Sine of pi, though, is 0, and so our slope is just negative 1. And so then we're ready to go ahead and write our equation. We know our partial equation is negative 1x plus b. Let's put our x and our y values in. Our y value is negative pi over 2. Negative, our x value is pi over 2. And if you solve for b, I think you can see that b equals 0. And therefore, the equation of the tangent line is simply y equals negative x. So a very simple one, actually. Okay, so you're going to go ahead and practice some of these trig derivatives. Thanks.